Okay, we're going to do another one of my 8 steps for adding fractions videos. There's 3 fractions, and remember this method works whether there's 2 or 3 or 5 or 100, it doesn't matter. I like to use 3 because it helps us understand building the least common denominator a little bit better. The first thing I'm going to do, step 1, is we write the denominators off to the side. So we're going to write the 12, 18, and 20 off to the side. Step 2, we factor the denominators. So 12 factors into 2 times 6, which is 2 times 3. And the primes, of course, are the 2, 2, and 3. Then we factor 18. And of course, we're going to get 2 times 9. The 9 breaks down into 3 times 3. So the primes are going to be the 2, the 3, and the 3. 20 is going to break down into 2 times 10. And 10 breaks down into 2 times 5. The primes are going to be the 2, the 2, and the 5. Step 3 has us rewriting the fractions using the factored denominators. So I'm going to write 5 over 12, but instead of 12, I'm going to put the prime factorization, which was 2 times 2 times 3. Instead of 7 over 18, it's going to be 7 over 2 times 3 times 3. And then the last one, 3 over 20, of course, is 3 over 2 times 2 times 5. Step 4, we draw a long line under the fractions. And then I want to build my least common denominator. Well, my least common denominator has to have everything I see here down here. But I don't want to repeat stuff unnecessarily. So I have to go methodically, one fraction at a time. This says I need 2 2's and a 3. I don't see anything down there, so I'm going to put both of the 2's and the 3. So I put the 2, 2, and 3. The next fraction says I need a 2 and 2 3's. The 2, well, I got extra 2's down there, so I don't need to see any 2's down here. But it says I need 2 3's, and you remember, some of this stuff is already down there. Well, the stuff that's not down there, we have to put down there. So I'm going to put that other 3 down there, making it 2 times 2 times 3. The last one says I need to see 2 2's, which I have, but I also need to see the 5. There's no 5 down there. So I'm going to add the thing that was missing, which is the 5. Now at this point, I found my least common denominator. I know that it's going to be 180, but I don't care. I'm going to continue to use the denominator in this form by simply writing a copy of it up above each of these fractions. Now the reason I'm doing this is because if I wanted to find out what the fraction would look like if I had 5 over 12, only it had 180 as the denominator, well, I'd take 180 and divide it by 12. And so by simply canceling the factors in 180 with the factors in 12, whatever's left is what I have to multiply the numerator by. So I'm just going to cancel the 2's, cancel one of the 3's, and what's left is I've got a 3, a 5, and the 5. So 3 times 5 is 15, times 5 is going to give me 75. On the next fraction, well, the 2, I'm going to cancel a 2. Both of the 3's are going to cancel. And I'm left with 2 times 5, which is 10, times 7 is 70. On the last one, both 2's are going to cancel. And the 5 will cancel. And 3 times 3 is 9, times 3 is 27. At this point, all I have to do is add my numerators, multiply the denominators, and I have my answer. This is just simple order of operation stuff. Well, 75 plus 70 plus 27 is going to give me 172 over the 180. Now, I know that this is actually going to simplify because 172 and 180 are clearly divisible by 2. But even before I multiplied this together to get 180, I saw the 172 ended with an even number, and I knew that 180 had a 2 in it, so I knew it was going to get a little better. A take the 180, 2, 2, 2, 3, 3, 5, and the 172, I'm going to do a little factor tree on it. So I'm going to write it off to the side. And it turns into 2 times 86, and the 86 turns into 2 times 43, and 43 is prime, so I'm just going to write the 2 times 2 times 43 up there, and we can see that the 2's are going to cancel, and what I'm left with is 43 on top, and 3 times 3 is 9, times 5 is 45 on the bottom, and that's my answer. Reduced. Doesn't get any easier than that.